Welcome to our video on working with estimators, where we go into more detail on getting the most out of the tf.estimator module. I'd like to start off by showing how simple it is to set up the TensorBoard projector when using an estimator. Since I've seen some confusion on this issue in various places online, and the process is much simpler than you might expect. Next, we'll learn about the ins and outs of the training hooks on the tf.train module, and we'll also see how we can easily create our own custom hooks. Finally, we'll show how to export your estimator model, which will take the place of the saved model builder we saw in video 1.5, since tf.estimator will use a saved model builder itself under the hood and it'll take care of all the details. Although we introduced the TensorBoard projector in the previous video, we did not go over the process of linking your labels to the data points shown on the projector. Recall this screenshot used to introduce the projector, which shows a bunch of word labels in the embedding space. The default appearance just shows these as dots, and we have to tell TensorBoard how to replace the dots with labels if we want ours to look the same as the screenshot. The documentation on how to do this doesn't really exist right now, but luckily it's very straightforward. Let's just go switch over to our editor to see how it's done. Here's the familiar glove embed function we saw in section 3, but I've added some additional code that allows the TensorBoard projector to access the unique labels for all words in the embedding space. Specifically, I've added the function at the end, if projector path is not none, and a new argument, init embeddings projector. If you pass glove embed a projector path, which is typically the same as your model directory, it'll call this new embeddings projector function, which sets up the projector, defined here. Only a few lines of code. The setup consists of defining a projector config, which is a simple protobuf object consisting of a list of one or more embedding info objects, which we pass to the constructor as seen here. Next, we'd like to call the visualize embeddings function. This will save our config in protobuf text format, and TensorBoard will automatically know to check if such a file exists when we open the projector. In order to call visualize embeddings, we must pass a file writer, so we create one and specify the directory we'd like it to save events to. That's it! The TensorBoard projector is now ready to go. A common misconception I've seen is people thinking they need to do something special after each training step in order to update the projector. Fortunately, there is no need to do anything like that, since TensorBoard will display the projector for the most recent checkpoint file found in the logdir, which means it'll grab the most up-to-date values of the embedding tensor we want to visualize. Since each data point is associated with a unique label, the corresponding word, and since that doesn't change, there is no reason to update anything special for the projector after each training step. Now on to training hooks and exporting models. When I first heard about TensorFlow estimators, I was a bit skeptical that I'd be able to customize the training process as much as I could using raw sessions. It turns out that most customizations can be done using training hooks, which are tools run in the process of training and evaluating a model, and they're located in the tf.train module. Let's see some useful hooks provided by TensorFlow, and then we'll see how we can create our own custom hook implementations for anything else we might need. Previously, we've used this within the body of our model function and passed the tensors we want it to log directly to the dictionary and its constructor. Here I'm showing another neat way you can use it without even needing to direct access to the tensors you want to log. We simply pass a dictionary where the keys are the names we want to print out and the values are the names of the tensors whose values will be logged next to the given name. I've also shown how to define your own custom formatter, called myFormatter right here. That formatting is for the output logs, so if you don't like the visual aesthetics of the default logging, you can customize it with your formatter function. All that's required is that your custom formatter takes as input a dictionary from tag to tensor and returns the string to print for the logging step. Note that although the documentation says tag to tensor, what they really mean is tag of value of tensor for that time step, which will usually be a float or integer value or a matrix of values depending on whether the tensor is a scalar or a multidimensional object. So that's one example of creating a training hook. To use the hook, we pass it to the train and evaluate function below, which we call right after making our estimator. You'll notice how the appearance of this code looks slightly different than before. Instead of handling the train evaluation loop ourselves, we're now using the new tf.estimator.train and evaluate function, which cleanly handles this for us. It accepts a train spec and an eval spec object for customizing the behavior for training and evaluation stages respectively. Train spec and eval spec are just named tuple objects. Train spec has the fields of input function, hooks, max steps, while eval spec has input function, throttle sex, steps, as well as a few others such as name, exporters, start delay sex. For now, just notice that we pass our logging hook to the train spec here. Another place that we can pass hooks to is within the constructor of the estimator spec objects we return from our model function. In this video, we'll be making a simple custom early stopping hook, which will terminate the training evaluation loop once our accuracy reaches a certain threshold. Before showing how to write our custom hook, let's go over the basic process of making a custom session run hook in general. We're going to our hooks.py file. Similar to the estimator template I made for section 2, I've also made a template for running your custom hooks, which I've called the tutorial run hook. It contains all the documentation you need for any part of your custom hook in an organized way that makes it easy to reference. First, all custom hooks must subclass tf.train.sessionRunHook. Then we must implement one or more of the 5 possible methods of a session run hook seen here: begin, after create session, before run, after run, and end. And this is how the methods are called under the hood right here, starting with hooks.begin, so that you have a good idea of which code goes where. So we can walk along here to see how these are actually used. Any code that we want executed immediately before any session goes inside begin. Any code that we want executed immediately after the session is created with access to that session and the associated thread coordinator goes inside after create session. Then the code that will loop over session run calls calling before and after run each iteration, which will each give us access to session information. And once a stop is requested, or an out of range or stop iteration error calls, all of our hooks.end methods will be called. Let's look at these in some more detail. So I seldom use begin, which is called before the session, since that's essentially run in the same context as any of our model function code, and such code usually belongs in the model function instead. The most common methods you'll implement are the before run and after run methods, which allow us to customize what is run in the session at each step and what is done with the outputs of the run calls. Before run provides us with a tf.train.sessionRunContext object, which is a simple object with the properties original args, session, and stop requested, with definitions provided here in our docstring. Often we won't even use the run context since we typically just want to add some tensor to the arguments being fed to the session run call, which is about to happen. And to do this, we return a session run args object that contains the tensors we want to add to the upcoming session run call. A session run args object is literally just a named tuple with identical fields to the parameters of session.run, fetches, feeddict, and options. The other main method you'll use is after run, which provides you with all the information needed to perform some action after a session run call. Again, it gives us the session run context, but this time we also get the session run values, which contain the output of the previous session run call. This is where the bulk of your code will typically go, since we usually make hooks so that we can do some specific set of actions after each call to session run. Note that we don't return anything in this implementation, and if we do, it will not be used. And lastly, we can implement end, which is called just before closing the session. If our custom hook saves anything to disk, this would be a good place for that code. Alright, now that we've got the general overview, let's implement our own. As mentioned, we'll be implementing an early stopping hook, responsible for terminating training once some given metric, usually accuracy, exceeds a specified value. We are of course free to define our init method, which will accept the metric we want to track, as well as the maximum value optionally, which will default to 0.99. And it then simply stores those two as as attributes, self.metric and self.maxMetric. Now before each session run call, we just want to make sure that the metric will be run so that we can access its value afterwards. Therefore, our before run simply returns a session run object containing our metric, which means that the upcoming session run call will add this to the fetches argument of session.run. Moving on to after run, after each session run call, we just need to check if our metric has exceeded matched metric, and if so, to request that training be stopped. The run values given to us only includes what we return in the before run call, namely the result of running self.metric, which is a 2-tuple of values, just like any metric from tf.metrics. We extract the first value, although the second value is fine too, since both elements of a tf.metrics tuple will evaluate to the same thing. If the value is over max metric, we'll issue a logging message that early stopping has been triggered, and then we'll call runContext.requestStop. Unfortunately for us, the implementation right now, TF Estimator Train and Evaluate, is very opinionated, something I really hope TensorFlow fixes in the future, since it can become quite annoying for reasons like this. Essentially, Train and Evaluate will just keep running the train and evaluation loop until max steps is reached, paying no attention to request stop calls being issued. For us, this means that although the training loop we're going to be in will be correctly stopped when we do this request stop call, it will proceed to evaluation and then just try and go back to training afterwards because, again, Train and Evaluate will not stop the train eval loop unless max steps has been reached. This means we have to be a bit more forceful to truly break the loop, and we must raise an exception. We raise system exit in our main function. We have a try and except call. I'll switch back real quick so we can see that. So back in our main function here, we have a try block which calls this train and evaluate loop, and it catches any system exit calls and acknowledges that that means early stopping has happened. So not the most elegant solution, but until TensorFlow fixes this, we will have to work with it. And if you want to see where we instantiate this early stopping hook, it is within our main function, so I'm just scrolling up to the end of our main function right now. So right before we return, we say we want our early stopping hook to track accuracy, and for right now, I'm playing around with the value of 80% accuracy. Usually it's much higher. That's why the default is 0.99. And then we just add it to the return training hooks, and you'll see here I have this ops hook, which is a custom ops hook thing. You can read more about that in the hooks.py file. But now I'm going to go back down to our main function, and we're going to go over exporting our model and what the processes involved with that are. Remember how we introduced the saved model builder in section 1 as a newer way to save our TensorFlow models? Well, when using an estimator, it's actually simpler to use the even newer export saved model method of the estimator class. We'll eventually call that at the very end here after we've terminated the whole training and evaluation loop. So just so you're aware, we're going to be calling export save model the method of a tf.estimator. I'm going to scroll back up though so we see how to set that up. Currently there are two possible approaches for exporting our model in this way, and we'll go over the approach that isn't nearly as well documented, since otherwise you may get a bit frustrated deciphering it alone. I know I was. The approach I am referring to is exporting our model using a raw receiving function, as opposed to the other approach with a parsing receiving function, which requires that your prediction model read in tf.example protobufs. The raw approach, which we will do, corresponds to a model that accepts tensors directly for its inputs at serving time. To do this, we'll start by calling the build raw serving input receiver function. As I've written in the comments, our use case is simple and we can actually implement this entire function ourselves with the same amount of code. The implementation I'm talking about here is this. So this function here in the comments is actually doing identically what this one is doing here. But we're going to be using the actual TensorFlow function because this is what you're going to use when you have more complicated use cases that can't be as simply implemented yourself from scratch. Again, I want to emphasize that the whole point of what we're doing right now is to specify our input function essentially for when the model is being served at a later time. To do this, we need to tell TensorFlow two things, both when someone calls my model with some inputs, I want those to be grabbed by my receiver function, which will convert those to features. It looks silly for us because we don't need to convert anything. Our features, aka the output of our serving input function, are the same as our receiver tensors, aka the input of our serving input function. We're now done with the hard work involved with exporting our estimator, and we just need to call the export save model, as we saw was at the very end after training. Export save model, we pass the receiver function that we just looked at, and also the place or directory location we want to export our model. I've chosen to export it within the model directory under a subdirectory called exports. It's perfectly okay if this was a little confusing at first glance, but after reading through the documentation and rewatching the video, I hope you'll find that we've cleared up some of the holes in the documentation that aren't explicitly discussed. As always, make sure to read through the links here for an in-depth look at the topics covered today. Coming up next, training tips. Training a model can feel both like a science and an art, and we'll go over some principal approaches for tuning your model during the training stage.